morning. Yesterday we have learned about vector and parametric equation of a plane, and we said that in order to find the vector and parametric equation of a plane, we need two direction vectors and a point on the plane. Today we are going to learn about Cartesian equation of a plane, which is in this form: ax plus by plus cz plus d equals 0. In order to find the Cartesian equation of a plane, we need two things. So required two things. One, normal vector to the plane. Two, point on a plane. The normal vector n and point x sub 0, y sub 0, z sub 0, any point on the plane. If you look at it, if we have a point on the plane, there is infinite planes that passes through this point, so that's not enough to identify one plane. If we look at normal vector also cannot identify a plane, because this is a normal vector to this plane, and this is also a normal vector to this plane, and this is also a normal vector to this plane, and this is also a normal vector to this plane, because the normal vector goes all the way, and there is infinite planes that are making 90 degrees with this vector. But if we say a plane that passes through this point and normal to this vector, let's say this vector, normal to this vector, there will be only one plane that is normal to this vector and passing and containing this point. So in order to identify one unique plane, we need a normal vector and a point. The coordinates of the normal vector will be a, b, and c, which are the coefficients of x, y, and z in the equation. And so if we have a normal vector a, b, c, we're going to put them in front of x, y, and z. And to find d, we are going to use this point. So we're going to substitute x by x sub 0, let's say 2, 3, 4. So we take x and put 2, we take y and put 3, and we take z and put 4. And so the only variable we will have is d. We solve for d and we find the equation of the plane. Okay? So let us have some examples. Example 1. Find the Cartesian equation of a plane that contains this point, which is, we call it a, 1, 2, and 2. And normal vector is perpendicular, the plane is perpendicular to vector negative 1, 2, and 6. So now we have a point a, and we have a normal vector negative 1, 2, and 6. So we can find the equation very easy. As I told you, we are going to write negative 1x plus 2b plus 6z, 2y plus 6z plus d equals 0. Then we are going to substitute with the coordinates of the point we have. So I will take x and put 1, I will take y and put 2, I will take z and put 2. The only variable I will have is d, so negative 1 plus 4 plus 12 plus d equals 0. Now we can say that d equals negative 15, so we can write the whole equation as negative x plus 2y plus 6z minus 15 equals 0. If we want, we can multiply everything by any number and it stays the same equation. So I can multiply this by -1 or not. It's up to you. Some people don't like to have a -a. And that's it. This is the equation, the Cartesian equation of a plane that is normal to this vector and contains this point. Okay, this is the first example. Example 2. Determine the Cartesian equation of a plane containing 3 points. This time they give us 3 points. A, -1, 2, and 5. B is 3, 2, and 4. C is -2, -3, and 6. So in this case, they give us coordinates of 3 points on the plane, A, B, and C. And they need to find the Cartesian equation of this plane. Okay, again, we have to stay focused and we know what we need to find in order to get a Cartesian equation of a plane. We need a normal vector to the plane and we need a point on the plane. Point on the plane, there is no problem. We have plenty. We have 1, 2, 3 points. We can use any one of them. Now the problem is how to find the normal vector to the plane. This is the problem. The problem to find, in order to find the normal vector of a plane, we need to think about what operation we know give us a normal vector. If we have 2 vectors and we need to find the normal vector to those 2 planes, two vectors. What was the operation we learned? Only one operation. So in order to find the normal vector, we have to do cross product of these 2 vectors, so we get the normal vector. In order to do that, I can make these 2 vectors, A, B, and AC. Those are 2 vectors. Then I do the cross product of these 2 vectors. I will find the coordinates of the normal vector. So AB, when we subtract B minus A, we get 4, 0, -1. Then we can do vector AC. This will be C minus A, which will be -1, -5, and 1. I subtracted. It doesn't matter. You can do BA and BC. You can do CA and CB. It doesn't matter which 2 direction vectors you choose. Any 2 direction vector in the direction of the plane, we get them, we get their coordinates, we do the cross product. So N will equal the cross product of AB cross product AC. We use the cross product I, J, K. We write the components of the first vector, and then we write the components of the second vector, and then don't forget here is plus. This is plus, minus, plus. If we do this, we get 3 components that represent the normal vector. I did this so I don't waste your time. This is the components of the normal vector. Now we simply can write the equation. So I will use without D. So we are going to write negative 5x minus 3y minus 20z plus d equals 0. Now we need to solve for d, so use any of these points. So let's say negative 5, I will use a, so negative 1 minus 3 times 2 minus 20 times 5 plus d equals 0, so 5 minus 6 minus 100 plus d equals 0, so this is the negative 101. So d equals 101. Then we write the equation in full. Negative 5x minus 3y minus 20z plus 101 equals 0. So in this we have two direction vectors. We have 3 points. We made two direction vectors. We did the cross product because this is the only operation that gives us a normal vector. We get the components of the normal vector, we put them here, a, b, c, then we used any of these points to get d, and we found this equation. Okay, this is example 2. Example 3. Determine the Cartesian equation of a plane whose vector equation, so we have a vector equation of the plane pi, r equal 1, 2, negative 1 plus s 1, 0, 2 plus t, negative 1, 3, and 4. We need to find the equation of this s and t, of course, are any real number. So they have the equation of the vector equation of a plane. Vector equation of a plane means we have a point on the plane, so we have this point 1, 2, negative 1, and those are the components of two direction vectors. Negative 1, 3, and 4, and the other one is 1, 0, 2. Now it became the same problem like the previous one. All we need to do is we have a point and we need a normal vector. Normal vector means we do the cross product of those two direction vectors. So I will say n will equal I, j, k plus, minus, plus. Put the components of the first vector. You can either use this one as first or this one, doesn't matter. Then we do the cross product, so we ignore the row and the column that has 0 times 4 minus 6 minus j, ignore 4 minus negative 2, so 4 plus 2, that's 6, 4 plus 2, k, 3 minus 0. So the components of the normal vector are negative 6, and 3. Now we can write the equation without d. Negative 6x minus 6y plus 3z plus d equals 0. We need to find d. We can use this point, so negative 6 times 1 minus 6 times 2 plus 3 times negative 1 plus d equals 0. This is negative 6 minus 12 minus 3 plus d equals 0. So negative 21, so d equals 21. We write the equation negative 6x minus 6y plus 3z plus 21 equals 0. And this is the required equation. Okay, we're going to continue in the second video. Bye.